In this unit, we're going to focus on solving equations. In this lesson, we're going to look at equations that require a little bit of simplifying before you can solve them.
Great. Hi, everybody. So in this lesson here, we're going to be solving what we call type 4 equations. And basically what we mean by this is it's going to require, it's going to require simplification first. Okay. A lot of the equations that we've been solving in the last few videos, that hasn't been an issue. That hasn't been the issue here. The issue has been just applying those operations and making sure that we've got them correct here. So now what we want to do here is we want to take a look at equations where we're going to need to do a little bit more before we get into the solving process. And we talked about this in an earlier episode where we were going to simplify first, and then proceed to the solving stage here. It's just that we haven't looked at a bunch of equations where we required simplification first. So what we want to do here is we want to look at equations here where we're going to have to combine like terms on either side of the equation. Now, once you've done that, it becomes a type 3 equation, something that we've already looked at. So we're always going to combine like terms on each side of the equation. So we want to simplify first. We want to make things easier for ourselves first by combining those like terms. And remember, just as a quick review, take a look at this. These are like terms, 3x and negative 10x, 2x squared, 17x squared, x squared y and negative 3x squared y, and then just 5 and 11 here. So remember that when we're talking about like terms, the variable portions with the exponents on the variables, those must all be identical. But it's like 7x and 7y, not like terms. 2x and 3, not like. 3x, and this is a hard one for some people, 3x and 2x squared, because the exponents on the variables are not the same, those are not like terms. And then over here, I got the y cubed and the x cubed, and those are different variables altogether. Now, another thing that you might consider here is if your equation contains all fractions, okay, for the constants or the coefficients there, one of the things you can do here is simply multiply the whole thing. Every term you multiply, and this is, you got to make sure you do this, every term on both sides, on both sides by the common denominator. Now, if you've not done that before, you'll see that in a few of the examples that we do. But that makes a huge difference in the simplifying. It's not necessary. It's not absolutely necessary. And we're going to have a quick look at an example here just to show you. So consider the following here. Two students decide to solve the equation. 2/3 x minus 1/2 equals 5/6. Okay, and these students choose to do it in two different ways here. So let's watch student A. So student A basically decides that they're going to just deal with the fractions here. So student A adds 1/2 to both sides. So on the left side, it cancels. They got to find a common denominator over here. So what they did here is they had 5/6, and then 1/2 became 3/6. And so together that is 8/6, which simplified down to 4/3. There was a common 2 in the numerator and denominator. Then they divided both sides by 3/2. Okay, divided both sides by 2/3, I should say. But that's the same as multiplying by the reciprocal. So 3/2 multiplied by 4/3 is going to be 12/6, which is just going to be 2. Now, student B, on the other hand, has a look at that and realizes that looking at the denominators, 3, 2, and 6, the common denominator, the lowest common multiple of those denominators is 6. Okay? Each of those denominators has a multiple of 6. So if I multiply the whole thing through by 6, 2/3 becomes 12/3, 1/2 becomes 6/2, 5/6 becomes 36, and each one of those can be simplified down. Whoops, I don't know why that's not doing that, to a nice value. Okay, so 4x minus 3 equals 5, and then we add the 3 to both sides and divide by 4. And we get the same answer. Okay, and that's an important point here. We get the same answer here. So the next question here that we've got is which of these, explain the difference between the two solutions. So the first student, okay, uses fraction arithmetic, whereas the second student removes the fractions. Now, which is correct? They're both fine. Both work. Now, which is more efficient? Probably number two. And the more comfortable you get with what number two is doing, the quicker it's going to work here. So because usually what happens here is people are far more comfortable working with nice whole integer values than they are working with fractions. So number two tends to be more efficient. Okay. And that is really because fractions usually slow us down. Okay. All right. Now that said, let's take a look at some of my examples. Okay, so our first question here says, just combine the like terms in the following expressions. So we're not even solving in this case here. We're just putting together the like terms here. So when I look at the first one, 3x minus 8x plus 7 minus 15. Oh, I did it again. Gotta remember to go back to the pen there. 3x minus 8x, 7 minus 15. So the 3x minus 8x, those are like terms. And 3 minus 8 is going to be negative 5. And then 7 minus 15, those are like terms too, because there's no variable there. And 7 minus 15 is going to be negative 8. And so there we go. And that's as far as I can go. I can't combine those two terms because I can't do the multiplication. I can't multiply the negative 5 by the x because I don't know what x is. So that's where I stop. Here for this one, notice I've got a 4x and a negative 2y, and I actually can't do anything with those two. That's it. But I can put 55 and negative 100 together, and that's going to get me negative 45. But that's about all I can do. There's really nothing else that I can put together there. And over here for C, well, I've got a negative 8n and a positive 47. So I can put those together because they're both terms that have the variable n in them. And what is it? 47 minus 8 is going to be 39. And then 58 plus 99 is going to be 157. Okay. So that's about as good as that's going to get here. Next, we're going to solve equations that require a little bit of simplification first here. So here we go. Maybe I'll do it like this. So on the left-hand side here, I've got the 8 and the negative 10. So putting those together, I'm going to get 5n minus 2 is equal to negative 17. Okay, now I've got it as like a type 3 equation that we've been looking at before. I'm going to add 2 to both sides, and so this will be 5n is equal to negative 15. Now this is like that type 2 that we were doing. I'm going to divide both sides by 5 to get rid of that coefficient, and n is equal to negative 3. Okay, there you go. And that's the procedure. Simplify what you're seeing on either side or both sides. That should take it to like a type 3 equation. Then we deal with the secondary term, okay, with addition, subtraction. And then we're going to deal with the coefficient, the multiplication or the division. So here on the left-hand side, the like terms, I've got negative 5k and negative 3k. So it's going to be negative 8k. And then the constants, 9 plus 8 is 17. Now what I want to do is get rid of, now that I've got it as two terms here, I want to get rid of that second term. And that's going to get me negative 8k is equal to negative 32. And now I'm going to divide both sides here by that coefficient, negative 8, and I will get that k is equal to, the negatives will cancel here, so k will equal positive 4. For this one right here, again, I'm going to put the b terms together. So that's going to be 5b minus b is going to be 4b. And then 8 plus 7, the two constants, is going to be 15. Is equal to 35. And now I'm going to get rid of or move over that constant term there by adding it to both sides there, or sorry, subtracting from both sides. So I will get 4b is equal to 20. And that's a nice one because when I'm going to divide now both sides by that coefficient of the b, and I will get that b is equal to 5. Okay, now this one right here, the reason why this one's here is because we want to take advantage of that, that little tool that they suggested before here, where what we do is we get rid of the common denominator. So what I'm going to do is I'm going to multiply, what have I got here? 2 and 3 in the denominator. So I'm going to multiply by 6. 6 is the smallest number that's a multiple of those two. So that's going to give me 6 over 2x plus 12 over 3x is equal to 90. And I'm going to simplify that. That's going to become 3x plus 4x is equal to 90, or 7x is equal to 90. Okay, this is actually became a, because of the like terms there, this became a type 2 equation, if you're kind of thinking back to a previous video here. So I'm going to divide both sides by 7. I'll get that x is equal to, well, 90 isn't divisible by 7. So I'm just going to leave it as that fraction, that improper fraction, 90 over 7. Okay, that's fine. This one right here, this next one, 4m plus 5m is 9m. Minus 2 is equal to negative 83. Now I want to get rid of the second term, so I'm going to add that second term to both sides, so that'll be 9m is equal to negative 81. And I like where that's going because I know that that 81 is divisible by 9, and that'll get me negative 9. And then lastly here, and notice what's going on in this one. And this one's a little different than the ones we've set up or we've just done here, because on the left-hand side where most of our work gets done, that's already basically simplified. On the on the right-hand side, this is where the work needs to be done. And 7 minus 15 is going to be negative 8. So now I'm going to subtract 8 from both sides to get negative 16. And then I'm going to divide both sides by 2 to get c is equal to negative 8. So yeah, again, all we're doing is adding a little bit of simplification prior to the act of solving when we're moving stuff around here. So now I tell you what, take a moment here, try some of these next few questions here. Okay, maybe pause the video here, take a look, try those guys. And then when you're ready, come back on and we'll go through and mark it. Or we'll go through and take a look here. On the other, I'm just going to jump right in. So on the left-hand side here, combining like terms, I've got 2x's and 3x's. That's 5x. Oh, actually, I'm going to do that with a different color. We'll make that black here. So we're going to make that 5x, and then negative 8, 9, and negative 8 is negative 17. And now I've got it in the form of a type 3, so I'm going to add 17 to both sides, which will get me 5x is equal to 30. And then I will divide both sides by 5, and I will get that x is equal to 6. On this next one here, you know what I might do with this one? And I don't have to really, but it makes a lot of sense here. Anytime I see a fraction in there, I'm tempted to multiply by the lowest common multiple of the denominator. Now, in this case, that's just going to be 2. So here that's going to get me 2 over 2x plus 4x equals 54. So that should be just x plus 4x equals 54. And then I'm going to combine the two terms on the left-hand side because they are like terms, and I get 5x is equal to 54. Now, that is like a type 2 equation from a previous lesson here. I will divide both sides by 5 to get that x is equal to 54 over 5. Okay, and my inclination is to leave that as an improper fraction. Okay, I got no problems with that. But there's no simplifying there. 54 is not divisible by 5. They have no common factors because 5 is prime. And now finally here, negative 2x plus 5. Those are the like terms. So I'm going to get positive 3x. And then 9 minus 14, those are our constants. That'll get me negative 5 equals 2. I've got the two terms. So the first thing I want to do is add 5 to both sides. So I get 3x is equal to 7. Ooh, and I can tell right from here that this is going to end up as a fraction because 3 and 7 don't have anything in common. And so I would just leave that as this improper fraction, x equals 7 over 3. So when you see a question like that, where you see like terms on either side of the equation, deal with those like terms first. Simplify them first. Once you've got it down to like 2 terms is equal to a number, get rid of the term that doesn't have the variable in it and use addition or subtraction to do it. And then you're going to use multiplication or division to move the coefficient out of the way.